Good morning, ladies and gentlemen, boys and girls, and welcome to the Street Science Virtual Classroom. What day is it today, Timo?
Wednesday, I believe, isn't it?
Wednesday morning it is indeed. Now, I'm pretty excited today because I'm joined by my mate, Timo Shea. Lots of you guys have gotten to know Timo over the last little while. How long have you been working at Street Science for, Tim?
About 3 months now, wouldn't it? So like end of January, so just over 3 months.
Wow. So Timo joined us for one of these broadcasts a few weeks ago, and we were making hand sanitizer, learning all about viruses and bacteria. I remember that was the first one. And then you covered last week. What were you doing last week?
The magic milk experiment, looking at surface tension. And we saw some beautiful artworks made by some junior scientists out there, which was amazing.
Pretty cool. In fact, it was a bit of a favourite. I came back into the lab on the Friday and I checked our socials. I jumped on Street Science's Facebook page and all these mums were saying, Tim's amazing. Can we have more and more of Tim? So you've got him. Here he is. He's in the lab. He's going to take one step to his left just to make sure he's as wide from me as he can because we're still in lockdown at the moment. And a lot of you kids are going back to school pretty soon, which is really, really exciting. Until then, let's continue these broadcasts. Timo, mate, we're in for a bit of a treat because there is stuff all over my bench top here today, which means, what are you doing, a bit of cooking or something?
Yeah, a bit like cooking. We'll be cooking up some Play-Doh this morning, so it's going to be lots of fun.
Make your own Play-Doh. Now, there's actually a couple of activities that are going to come out the back of our Play-Doh today, which is going to be really good fun. So stay tuned right to the end because this is going to link into another lesson, which we're going to run next week as well so that we can build. Now, check out the little poll wherever the button is. Let me do our housekeeping, Timo, real quickly. The chat room's not on today here, so if you've got comments, photos, all the good stuff, jump on the Street Science Facebook page and chat and interact with us. Tim, after this presentation, mate, can you jump on our Facebook page?
Yeah, I'll be going there, so I'll answer any of your questions that you've got. I'll check out some of the photos of the awesome Play-Doh that you guys make, and, you know, if you guys want to tell me that it's your favourite experiment again because I'm on, then go for it.
I doubt that's going to happen, Tim, because they love my broadcast so much, but you never know, right? You can build him up a bit. Timmy loves being told he's a legend. All right, chat room sorted. We've got polls and things like that and some little offers and links, all that sort of stuff. Now, Steam Squad has just launched. In fact, we're launching publicly, not today. I thought we were launching it today. We're launching it publicly tomorrow. So you guys get a head start. If you want some small class sessions where we can see you guys, you can see us. Timo, I think you're running some of these Steam Squad lessons as well. We've opened up Forces in Action for little dudes and then for some older kids. We've also got kitchen chemistry, which is going to be pretty exciting as well. We'll send you guys a list of all your materials that you need beforehand, and you can have them ready to go, and you can do it live, which is going to be awesome. All right, Timo, let's get started straight after
birthday shout-outs. So I've got Jesse turning 6 years old today. Jesse, happy birthday.
Happy birthday, mate. 6 years old.
Yeah.
What an exciting time.
Do you remember when you were 6, Steve?
Not really. It was a good 30 or something years ago. No, what about you?
Oh, barely. Maybe a little bit. Not much at all. But I hope you have an awesome day today, Jesse.
And you might be back at school soon, Jesse, because schools all over the country are starting to get organised, getting ready for everyone to go back to school. Alrighty. Making your own Play-Doh, Tim. Talk me through it. Why are we making some Play-Doh? Because I'm sure there's going to be some pretty mad science behind this.
Oh, it's fun. Well, firstly, it's fun, but we also get to learn a bit about chemistry, like how we combine materials together for like a particular purpose to try and make something new, make a new material.
Excellent. All right. Speaking of materials, kids who are following along at home are going to need a few different materials. Yeah, what are we going to need for today?
We'll need some cooking oil, some vegetable oil. That'll work perfectly fine.
Any old oil going to work?
Yeah, I think most oils should work. We don't need too much of it, so it shouldn't
there's only a little bit in there. So vegetable oil, cooking oil, any of those, it's going to be fine. Olive oil, I'd suggest so because I think the oil is simply going to lubricate and make it a bit more pliable anyway. So I think any of those oils are going to be fine.
I think you can do it without oil as well.
Just be a bit more grainy, maybe. Yeah. So we've got vegetable oil, black and gold, straight from our local IGA. Yeah. What else do we need?
So we'll need some table salt as well. We've got some just over there.
Beautiful.
Table salt. We'll need some warm water as well. We're going to get Brian, who's helping us out today, to grab us some warm water later on. We'll need a bowl that Steve's holding up to mix our materials in.
Is that one all right, Tim?
Yeah, that'll be fine. Or you can use big one, just like this.
What do you want? Do you want the little one or the big one, Tim?
I'll go the big one.
You would.
Big one for the big boy.
Little one for the little fella. All right, I might actually do this activity myself off to the side if that's all right.
Yeah.
You're teaching. I've never made Play-Doh, and I know my kids at home are probably foaming at the mouth at the moment, knowing that we're making Play-Doh, so I might make some and take it home to the kids. All right.
Yeah, final thing we need, just some flour as well, just ordinary flour. Just got some in a tub right here, labelled it flour.
Gluten-free flour going to be all right. Normal flour, self-raising flour. Do we care? Is there a difference?
I've got normal, general plain flour there. Brian's just got us our warm water as well.
Beautiful.
So yeah, I've got normal plain flour there. Gluten-free flour, it's an interesting one. I think the gluten inside our normal flour might help to bind our Play-Doh together, but I'm not entirely sure. So maybe if some of the guys out there have some gluten-free flour, they could try it out and let us know if it works.
Yeah, give it a go and jump on our socials, jump on Street Science AU on our Facebook page and let us know, because it might look and feel really different. Because if the gluten, I believe as well, Tim, like you said, that gluten does help it all bind together a little bit, which means it might be more grainy or a little bit more crumbly once you've made it. But the only way to find out is to experiment.
Yeah, exactly.
And that is key. Now, speaking of experiments, Tim, when we do experiments at Street Science, we love to follow a procedure. We have steps that we follow, and if we follow those steps, then we end up with some results that generally we're pretty happy with.
Yeah.
Can you show us the Play-Doh that you're making today?
Yep. So made some just before, and it looks just like this.
It looks
good. A hell of a feel.
All right. It feels amazing. There it is. Better hold it up nice and high. It's beautiful to play with. I could pull it apart and build all sorts of stuff with it. However, Tim, I did notice, now I'm going to drop Timo in it right here. He's not happy, right? Check it out. I actually found another tub of Play-Doh, which does not look anything like what it should look like, in a little tub over in the corner of the lab this morning when I came in, because Timo has been experimenting. And, mate, I don't even want to get it out. It's disgusting. Look at it. It's sticking. Oh, it won't even come out of the container. What happened?
I didn't follow the steps in the procedure. I added a little bit too much water. And then I did what I do when I'm cooking and I've added too much of the wet ingredients. I just added more flour.
Yeah, right. And it didn't work out. So if you don't follow the procedure, you're not always going to end up with what you think you're going to end up with. Yeah. Interesting. All right. So we'll get rid of that. It feels like dough. I'd be really interested to see what would happen if we stuck it in the oven. We'd probably make some disgusting bread. All right, let's get rid of that. We might take you guys down to our bench top in a moment, and let's get making.
Yeah, let's do it. All right. So I've got my nice big bowl here. Probably going to need to get you to throw some ingredients over towards me. So to start off with, we're going to grab 4 tablespoons of flour. So I've got a tablespoon here. You could just use a spoon that you've got at home. Now, we're going to use tablespoons for all our measurements this morning. So it doesn't really matter if you've got something else. Like if you're using cups, they could just make a lot more of it, as long as we have the ratio right between all of our ingredients. So we're going with 4 tablespoons of flour.
So it's all about the ratio, Timo.
Yeah.
So if we want to make a big amount, a large batch of Play-Doh, we could double, triple, or even quadruple the ingredients that we're using. Yeah?
Yeah.
Cool. So how many tablespoons are you going for right now?
So we're going with 4 tablespoons of flour. All right.
Then you're going to want some salt, I'm guessing.
Yep. Then we're going to want some salt. So let's get out our salt. And I've got 2 tablespoons of salt. So half as much salt as we have flour. Now, I've got my cup measurer here. I'm going to save this cup measurer for the oil. I don't want to dip this straight into our salt and contaminate it. So I'm going to pour some of my salt just into this cup here. Just open it up and pour some in. So that way I can dip my cup measurer into this salt and not contaminate all that salt there.
Very cool.
With
now,
yeah,
while you're
flour.
measuring, Tim, I am noticing that the salt you're using is cooking salt. It's not the big coarse chunks, which I think is going to be pretty important. Yeah, you don't want the big grain, not the grains, but the rock salt, because that would feel very different in your Play-Doh if the salt's too coarse.
Yeah, I could even feel small bits of the salt in this Play-Doh. So if you had that really big salt, it would be, you might be able to feel that. So we'll just pop this to the side for the moment. I might leave that there for you.
Thanks, mate.
Steve. Let's give this a bit of a mix up. So I've got my spoon over here. So we're just going to mix our salt and our flour together. And now this process here, we're not chemically changing anything. It's just a physical change. If we got our microscope out, we might be able to look and pick apart the bits of salt and the bits of flour.
Interesting. So you're mixing and combining those materials. They're changing physically. Like if you stuck your hand in there, it would feel different to flour. It'd feel different to salt because it's a combination of the two, but you're not making any substance out.
No.
You're just mixing those two objects together.
No.
Very cool.
Yeah.
Physical change.
Physical change. That's it. All right. So now the next step, we've got our warm water next to us. We're going to need to get 2 tablespoons of water. And this water needs to be warm. So we've just turned the hot tap on at our sink. Got a bowl full of hot water here, thanks to Brian. I'm just going to grab this cup that's right over here and get my measuring tablespoon. I'm going to grab 2 tablespoons of my nice warm water. Just pop it into this cup.
I'm just taking notes, mate, so that
there's
I can make this at home later.
And here's 2. Now, probably the most important decision I'll have to make today, what color my Play-Doh is going to be. I'm going to go with, I'm wearing a red shirt. Let's go with red. All right. So pop some red food coloring in.
Now, you're using a generous amount there, Tim. I see. Just like lots of the kids out there, where we go and say, put 2 drops of food dye in, you know what they do? They drop about 10 drops in.
Yeah.
You're aware of that? So let's tell them, how many did you actually put in there?
I think I put about 5. So 2 drops, guys.
2 drops, kids, is perfect. 2 drops of food dye into your water, which means a little bit more. Okay,
yeah,
perfect.
I don't think you need to tell them that, Steve.
They're going to do it anyway. Yep.
All right, so I've got our 2 tablespoons of water. We've dropped our food coloring into there. Different changes happened here when we've combined them. This food coloring has what we call formed a solution in our water. So yeah, it's spread out nice and evenly, and now all of our water is nice and red. All right, next up, we're going to add some vegetable oil. So we need 1 tablespoon of our oil. So I've got vegetable oil. You guys might have a different type of oil. That's perfectly fine.
Now, while you're measuring your oil, Timo, just going to take a moment to note that you're not cooking your Play-Doh. I've seen lots of recipes online, and I know you've chosen this recipe especially because we want to make sure that these activities are accessible for you guys. And there's lots of recipes out there where you need mum and dad to be there on the stove, heating things up, cooking it the whole time. The quality of the Play-Dohs do improve to a degree when you go and heat them up. But this is a really good recipe, considering that we're not going to cook it on the stove.
Yeah.
So really good choice. And I think that's why Timo's actually chosen this recipe. There is a really similar recipe that uses cream of tartare as well. And that cream of tartare, I believe, just helps as a preservative. So if you want to add a little bit of cream of tartare, like a tablespoon, you're welcome to do that at this point in time.
Yeah.
But Timo's not doing it.
No.
It's a preservative. So if you want your Play-Doh to last longer, or you're finding that there's some bacteria growing on it, or it's crumbling too soon, then maybe try adding that cream of tartare as well.
And I think it also helps with the elasticity of your Play-Doh as well.
It does too, making it stretchy. That's a good word. Say that again.
Elasticity.
Elasticity, the ability to stretch.
Exactly. All right, so I've got my tablespoon of water mixed in with, my tablespoon of oil mixed in with my 2 tablespoons of water. All right, now what we're going to do is we're going to add our wet ingredients to our dry ingredients. My sister's a very good cook. I'm not a very good cook. She always tells me that you should add the wet ingredients to the dry ingredients and do it nice and slowly. So I'm going to follow her advice and do that right now. All right, let's add it nice and slowly.
What's your sister's name, Timo?
Christina.
Christina, shout out to you, Christina. I'm sure you're tuning in today, watching Timo at work.
Oh,
shout out to you, Christina.
Or she might be hard at work at university back in Wollongong, studying away.
All right, I'm going to stay nice and wide, but I want to look over the top of this, Timo, because it's starting to clump together. Interesting. It's definitely starting to change.
So, yeah, we've added some water and all that to our flour and our salt.
Now, while you're mixing, Timo, I'm just going to repeat the ingredients and the quantities, because there's some people on social media right now saying, Timo, what were the quantities? So let me check it because I wrote it down. 4 tablespoons of flour, 2 tablespoons of salt, 2 tablespoons of water with the food dye, and 1 tablespoon of oil. So really simple ingredients. 4 is to 2 is to 2 is to 1. Very good. All tablespoons as we go. A couple of drops of food dye. Timo's gone for red because he loves the colour pink, and that appears the colour that it's turned into, mate. So maybe if we used even more food dye, I'd go darker colour.
Maybe I should have gone for 5 kid drops.
Maybe, which is what, 10, 15?
Yeah.
In reality. All right. Yeah. That's looking really good, mate. So
just
once you've made it,
it,
you just have to knead it then?
Yeah. Just keep pushing my hands through it.
All right, cool. Now, Play-Doh is brilliant, right? You've all had Play-Doh as you kids were growing up, I'm sure, at different points in time, but to be able to make it yourself and then play with it, it goes next level, right? Because you've combined everything. Now, Tim, a question that always comes up when people make Play-Doh, right? Is it edible?
Is it?
Can I eat it? What happens if my little brother plays with the Play-Doh and sticks it in his mouth?
Well, you know what's that? Like, what have we put in it? We've got flour, that's edible. We've got salt, that's edible. We've got oil, it's edible. We've got water, that's edible. We've got food coloring, that's edible. But I think the only problem for me is that my hands, I forgot to wash them before we do this.
Oh, no.
Naughty me.
Really?
So I probably wouldn't eat this because you don't want all that gross stuff on my hands. So
technically it is edible Play-Doh. However, we don't recommend it. It's not going to taste good. There is nothing tasty in that recipe at all, which is probably a good thing because it's going to probably not encourage you or discourage you guys from eating this stuff. But if somebody is consumed, it's not the end of the world. But it's probably more so the bacteria and that sort of disgusting stuff that's on your hands that's going to get in there.
Yeah, because it's food for them as well, like they'll love all this food and it's a great place for all those yucky germs to grow. And so, you don't want to be eating those.
Now, just quickly, Timo, as you knead it and you rub it, a shout out to all the grade 6 kids at St. Joey's in Bracken Ridge because they are learning about prefixes at the moment, and I just dropped the most amazing prefix. Can't even remember what the word was. Discourage. So instead of encouraging, I've dropped dis at the start, which is a beautiful prefix. Flips it around, discourage. So shout out to the grade 6s at St. Joey's. I know there's a lot of you guys tuning in today.
Yeah, so you could also talk about adding your cream of tartare before as a potentially like a disinfect, get rid of that stuff.
Disinfectant?
Yeah.
Oh, it's a preservative. So a disinfectant or a preservative?
Yeah.
I'll dive in it. Anyway, prefixes, they're pretty cool, Timo. All right, let's focus on the Play-Doh. Can we stand up? Because I think everything's been made.
Let's do that.
Let's check it out now. When you make Play-Doh, Timo, and I know you do it a fair bit because you're a bit of a crafty cat, what do you do with it? Do you make anything in particular? Or do you want to set a challenge for the kids out there today with their Play-Doh?
So the reason I chose red is I want to make this Play-Doh look just like me. Okay. So I made some Play-Doh earlier. I'm going to try and make this Play-Doh look just like me. So see if I can do it. How do I do this, Steve?
So you're going to mold the Play-Doh.
I'm going to mold the Play-Doh, make it look like me. So I'm trying to do 2 like 2 little legs there.
Oh, I thought you were trying to do your head, Timo, because your
No.
head looks a little bit like a potato, as does the Play-Doh right now. Ooh.
So I'm just going to do some arms. Make sure
Okay.
I've got big muscles on the arms, right?
Yeah, your big guns.
Yeah, the big guns. Should I draw like a little smiley face?
I tell you what.
2 eyes and a big smiley face. You know that I was also very good at art in school, as you can tell.
I can tell, yeah.
Does that look just like me?
No, it looks nothing like you. So let's set a challenge. All right, kids, once you go and make your Play-Doh, the challenge is for you to make some artwork that looks like a sculpture, that looks like my mate Tim, or looks like Science Steve. All right, we want photos, and we want those photos dropped into our social media, straight into the Street Science AU Facebook page. And then what we can do, Timo, you can jump on and you can actually check them out.
Yeah.
And you can give a little bit of feedback. We'll try and work out, I'll jump on as well. We can try and work out whether they've actually done an image of you, right, with your big guns.
Yeah.
Right? Or me with my spiky hair. All right, that might be the only 2 things that they can
Yeah.
do. Maybe they'll make you really tall and me really short, because I am a little fella compared to this mammoth bloke beside me. All right, cool. So make some sculptures, right? You can even make a little special something for Mum for Mother's Day.
That's a great idea.
Timo, when this Play-Doh dries out, what happens to it?
Some of the water evaporates out, and then I'm not actually sure.
I think it goes hard.
Goes hard?
It does go hard and a bit crusty. Yeah. It does sort of compress a little bit and start to crack a little bit, but you can actually end up with a little hard creation, a little sculpture.
Yeah.
Not as good as clay, but it's pretty cool. So how about kids, make something for Mum for Mother's Day, right? She'll love it. And how about you make some little sculptures of Timo, myself, and get those photos up on our socials.
Might give a shout out to the one that looks most like me and Steve next week.
Timo, question on our Facebook page. If we go and add the cream of tartar? I say tartar.
There's no
E. Tartar. Cream of tartar. Do we need to add more water or more oil? No, you don't. All right. So the ratios we've got are beautiful. If you're going to add 1 tablespoon of cream of tartar, you are most welcome to do that. You're not going to need to change the amount of oil or water. It's still going to bind beautifully.
Maybe a little less salt, because salt also acts as a bit of a preservative as well.
You could, but if you start messing with the recipe, Timo, I've seen what happens. I don't even know where it went.
Where'd it go? No, we got rid of it. No,
you go start messing with the recipe, Tim. It's not pretty. I thought you would have learnt your lesson. Obviously not. All right. So 4 tablespoons of flour, 2 tablespoons of salt, 2 tablespoons of warm water, did you say?
Yes.
With some food dye, 1 tablespoon of oil, mix it all together and knead it, and you're away. I want to see those sculptures. I'm looking forward to it.
Yeah.
Because they're going to probably come up today, because this one doesn't take long for them to play with. Yeah. You can even make one of Timo in one colour, one of me in the other colour, and have them standing side by side. That'd be sick. Yeah. All right. Timo, I've been getting a lot of feedback from people on social media, lots of emails rolling in as well, because they've been watching you in the Learning Lab. All right. I think last week we released a couple of videos of you teaching the kids all about the planets and the order of the planets, and also the size of those planets compared to Earth and the Sun. I actually watched that episode. It was really cool. I learnt a lot. And you taught us a little jingle as well.
The mnemonic.
The mnemonic. What was it? How do we learn? All right. Here's a little taster of what's in the Learning Lab. How do we learn to remember the order of the planets, Timo, in our solar system?
So we've got that mnemonic. Let's hope I can remember. I filmed this quite a while ago, but it goes, my very excellent mother just served us nachos. So the way a mnemonic works is you grab the first letter of all of those words and use that to remind you what planet it was. So we go my, and we remember Mercury.
Yep.
Very, we go Venus. Excellent, we go Earth. Mother, we go Mars.
Yep.
Just Jupiter. Served Saturn. Us, Uranus. Nachos, Neptune. That's how we can remember the order of the planets in the solar system as we go away from the sun.
That's pretty cool. So that's down in the Learning Lab with a bit more detail and some worksheets and stuff that you can do. But people have been saying, sorry, I got distracted, Timo. people have been asking whether they can get to know you guys a little bit more and you see your personalities because they love you so much. So I'd love you to come back and do another episode. In fact, you can run one yourself, mate, next week. Next Wednesday. Does that suit?
Yeah, that sounds good. Been looking to kick you off eventually.
Okay. What are we going to do, though, next Wednesday?
I think we could step this up a little bit.
Mm-hmm.
We've made some Play-Doh today.
Yep.
But I think next week we could make some conductive Play-Doh that might light up. That's possible.
Okay, so conductive Play-Doh means a type of Play-Doh that will allow electricity to run through it. So next week we're going to need very similar ingredients, in fact, the exact same stuff, plus some sugar.
Yep.
Right, and we're going to make 2 different batches. We'll make a batch. In fact, we won't because I won't be here. It sounds like you're kicking me out for real. Tim will make a batch which is conductive. Electricity will run through it. We'll make a batch which is non-conductive, so electricity will not run through it. And then what we can do, if we can get our hands with Mum and Dad's help on a battery, like a little 9-volt battery or a AA battery, and some little LED lights, just like the ones you find in these kits. Now, we sell these on our online store, DIY torch kit and a flashing keychain kit. The little LEDs, you can pick them up from Altronics, J-Car Auto, J-Car, those sorts of shops, just little LED lights. You will be able to wire up these little creations that you make with Play-Doh so that the lights come on and flash and do all sorts of mad stuff.
Yeah,
so,
sick.
Big episode next Wednesday. Timo's going to take your Play-Doh next level to make it conductive and non-conductive and build some stuff which lights up.
Just noticed I've got a really good question from someone. Has it chemically changed now that it's finished? That's a fantastic question. I was looking into this last night because I'm making some Play-Doh. Better be able to explain some science about the Play-Doh. So what I found is that in our flour's got a lot of what we call starch in it. And that starch is bound up into these granules. They're like it sort of spirals around. And then when we add our warm water, these granules, they sort of open up. The actual molecules in there, they don't change at all, but they open up. They change their structure, sort of.
So they're not binding to other materials and chemically binding, but they are physically changing almost like their shape.
Yeah.
Interesting. Now, the question of a chemical change versus a physical change is a really good one because we teach chemical and physical change in high school, right? We use different language normally in primary school, which is a lot of our listeners out there, probably in primary school, Timo, I'd suggest. In primary school, we use the language reversible versus irreversible, right? So at that level, I'd say this Play-Doh would be very difficult for us to reverse. I don't know how I would be able to get the oil out of there. Like I'll get the water out because I could just leave it and dry it out and let it evaporate or put it in an oven or a kiln. That would work. But then dividing the salt from the flour, being able to separate all those materials and turn it back into what we started with would be really tricky.
Be pretty difficult.
So I'd suggest we would classify it generally as irreversible at this point in time.
Yeah, I don't know how I'd reverse that.
But if I was working with some secondary students in grade 9 or grade 10, and we were talking about chemical changes and chemical reactions, I would suggest that there haven't been any chemical reactions that I can think of in this. If we heated it up, if we used one of the other recipes that you can find online where you're heating it up and you're cooking it, I'd suggest that perhaps some chemical reactions would be taking place there because the heat encourages those reactions to take place quicker and more easily. But I don't believe any chemical reactions have taken place here, making new substances. We've still got a big mixture of all those ingredients together.
Yeah, we've just changed them around a little bit.
So I'm going to say irreversible at this point in time. But try and reverse it. Try and break that down to the original products. If you can do it, you are a dead set legend. Send me a photo and tell me how you did it. Final question, Timo, because we've got to get out of here, and I know you want to go make a cup of tea, get upstairs and jump on the socials to interact with our wonderful viewers from home. Why do we need to add oil to the recipe? From Aaron, who's 9 years old. Timo, what's the oil doing?
I'm not completely sure, but I think the oil just helps it Yeah, I'm not sure, to be honest.
I would suggest that it's helping those ingredients bind together. So if we didn't have oil, and we don't have that much water in there, 2 tablespoons isn't a whole lot, that oil is going to help it bind. But very importantly, it's going to help to lubricate those particles as they're trying to push past each other. It's making it less crumbly and making it, I don't know the word to describe, the ability to squeeze it and let those little particles rub past each other.
Yeah, it's sort of almost malleability, you might.
Very
ways.
good. Malleable. That's a great term, Tim. Malleable.
So it's a bit like when I like to make scones sometimes, and I get my flour, and it's all very floury and soft and doughy, and then I add some butter to it, and it becomes a bit like our dough there.
Interesting.
So it might be similar to that.
Very good. Anyway, Tim, I'll answer the rest of your questions. Jump online and try and stump him with a good question. Yeah, I'm going to get out of here, Timo. I think it's just about the end for us. Feel free to run on through to our shop, guys. I think there's a link somewhere to check it out. Steam Squad. The tickets for Steam Squad, which kicks off next week, I think, on Tuesday and Thursday. The tickets are through our online store, which you can be found on our website, streetscience.com.au. If you want to get your hands on some little LED lights, if you buy these today, I reckon we can get them in the post this afternoon. And you should have those sitting in your hot little hands by next week when we're actually doing some conductive Play-Doh, making conductive Play-Doh and messing around with lights. That might be handy. Or just go to your local little electronics store and pick up some bits and bobs, a couple of LED lights, some little wires, whatever you want, have some fun. Timo, anything else?
Any other specials in the shop, Steve?
Oh, mate, there's heaps. There is a special actually. Chemistry bar sitting behind you, Timo.
I'll get out of the
Anyone
road.
who buys the chemistry bar, I think we're throwing
One
in
of these guys.
Oh, let me
So they buy a chemistry bar, and what do they get with it?
Okay, can you see this little fella floating at the top? He's called a Cartesian jellyfish, and what he does, he's a diver. So if you squeeze, I've got to do it with my right hand because I'm not strong enough. I haven't hit the gym lately. If we squeeze the bottle, can you see that little jellyfish? Oh, sinking to the bottom. So I'm changing the pressure in the bottle, which changes the level that Cartesian diver is going to cruise around at. You can see his legs going up and down. Now, I heard you have one of these beside your bed, Timo. Is that right?
Yeah, just been working on, these muscles don't come out of nowhere. So before I go to bed each night, just a bit of
few
squeezing.
To bulk up. Nice work. All right, we've got to get out of here, mate. Tomorrow, Jess is coming in because I don't do Thursdays. Jess will be in. I heard that she's making rock candy. So you're going to need some sugar. You're going to need some water. And probably a little bit of food dye if you want some coloured crystals, but that's just about all you're going to need, I think. Maybe a bowl to mix it in. And some warm or hot water. Jess will walk you through it. We're going to get out of here. And a stick or some string.
Maybe like a toothpick, maybe. Something like that.
A skewer.
Yeah.
That'll work
skewer.
really well.
Skewer would be perfect.
Something to allow the crystals to fuse.
That'd be fun. Like, our Play-Doh, not very tasty, but I think the rock candy might be it.
Are you suggesting that you're going to be able to eat those rock candies that she's making?
Maybe. You'll have to find out tomorrow, I guess.
All right. I'm going to get out of here, guys. Have a wonderful day. Thanks for tuning in. Until tomorrow. See you guys later. We love science so much here at Street Science. We teach kids about science and we do it in a really, really cool way. We're going to be teaching them the science of fireworks. We're going to be working with liquid nitrogen, some amazing visual stuff. It looks and feels just like smoke. Let's ramp things up a little bit. Who likes fireworks? I'm going to try and shoot these cups off your head. Not by using magic or anything crazy, just by using science that we can't see. Can you guys see a liquid in there? Look at that dark patch in the bottom. That's Laura's breath. can we sneak in one more quick demo? We love science so much here at Street Science.